Okay, guys. I was asked questions about section 4.2. I hadn't received any questions about 4.3, so I hope we're okay with that one. And so I'm going to be going through some of the solutions, talking through some strategies you can use, and then that'll be it. No new material today. We'll post the review tonight sometime. I will be working on that because primarily the internet at my house is currently down, and so I'll be running back and forth to the school to see if I can get some interwebs and make this happen. Okay, so let's start off with question number 13 from section 4.2. Okay. For the following exercises, consider this scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 people per year for 5 years. Number 13. Find the linear function that models the town's population as a function of the year t, where t is the number of years since the model began. Okay, let's start with some basics. Number one, we have an initial value. It is 75,000. Number two, we have a rate of change. That rate of change, it says, is 2,500 per year for 5 years. Okay, it says to write a linear function, where in this case we have to write a population, p, that is a function of t, where t is in years. Notice how we take the given information and just list out all the parts we know. We have the initial value, 75,000, the rate of change, which is 2,500 per year over 5 years, and then p of t, where t is in years. This p of t is important because it says in the town's population, capital P as a function, so capital P as a function, where in this case t is in years since the model year began. Alright, let's do it. So, on this particular function, we have here p of t. Whenever you're writing the equation like y equals mx plus b, remember m represents the rate of change, and b represents the initial value. Okay, so we have a rate of change. It's 2,500 per year. So in this case, instead of x, we're going to use t. And then we have an initial value of 75,000. Now to verify my results make sense, I'm going to test this. T versus p. Now, at my initial time, so that's when t equals 0, I need to check what the population is going to be. I need to make sure it matches the initial value of 75,000. Then I can use some logic and ask, okay, what's going to happen after 1 year, and then what's going to happen after 2 years. So, logically, this number should be 75,000. And it is. If I plug in t is 0, 2,500 times 0 is 0, plus 75,000 is 75,000. Now, if I'm just thinking about the problem, so I go over here to the problem itself, and ask myself, okay, based upon what they've told me, what's going to happen after 1 year? Well, in 1 year, I'm going to add 2,500 people. So my 75,000 is going to grow to 77,500. And the thing is, if I plug in 1, that's exactly what happens. If I plug in 1, 2,500 times 1 is 2,500, plus 75,000 is 77,500. After 2 years, the same process happens, except now we're at 80,000. And so it seems like this function is the right one. It has the initial value of 75,000, and it has the rate of change of 2,500. Now, number 15 is a little bit different. It asks, if the function is graphed, find and interpret the x and y intercepts. So I'm going to graph my function. Okay, so in this example, I'm going to count by 1, so 1, 2, 3, 4, and 5. And I'm going to count by, let's say, 10,000s. So 10, 20, 30, 40, 50, 60, 70. Oh, yeah, I need to change that. Or just do it crazy and do it in a different color. Alright. So, when we're at 0, we are at 7,500, which is right here. At 1, we're at 7750, which is right there. At 2, we're at 8,000. It's right there. And you can see how this is going to go up a little bit each time, giving me a rough function that looks kind of like this. Okay, I can see here we have a y-intercept. Okay, well, what is the y-intercept? Well, in this case, the y-intercept is 75,000. So the question says, find it. Well, we did. Now interpret it. This is the initial value. So that's the first piece. There's also one other intercept, because eventually this graph is going to touch way over here. Now, the way to find that, like, I could extend this graph and keep going, but that's not very useful here because it's going to be a pain to do. I could also find the x-intercept by using the equation and just set it equal to 0. So 2500t plus 75,000. Okay, this is one of the ways we can use to find the x-intercept. So notice I used the graph to find the y-intercept because that was easiest, and now I can use the equation to find the x-intercept because that was easy for the equation. I'm going to move the 7,500 over, get negative 7,500. That equals 2,500t, divide both sides by 2,500. And when I do, I will get t is equal to negative, let's see, 0, 0, 0, 0, negative 30. So I found it now. So when t equals negative 30, so at negative 30, our value would be 0. That's my intercept. Always make sure to interpret and get the actual answer here. The x-intercept is at negative 30, 0. What does this mean? Remember, this is the time, and this is supposed to be the population. So let's interpret. Well, if the time is negative 30, that means that, you have 30 years ago, because negative means backwards, so negative, it would be backwards in time. So 30 years ago, the population was 0. And there's my interpretation. Notice how I just take the information given from up here, the population in terms of time, and I write it as a sentence. The years, negative 30 means 30 years ago, and then 0 is the population, so this tells me that 30 years ago the population was 0. Whereas right now, the population is 75,000. Now, before we go any farther, let's make sure to reiterate a concept we had in our homework and in our notes. The concept was model breakage. Does this make sense? Like 30 years ago, is that reasonable to assume? And the answer is usually no. Like, most towns don't have linear growth. And if they do, it's usually over a short period of time. That's why in the problem it states it is for 5 years. And so we're looking at something that is 30 years ago. That's well outside the normal bounds. If it had been 1 year ago or 2 years ago, we could have a reasonable guess. But 30 years, when we only started with 5, that's unreasonable. And so we would say this has model breakdown. And that's okay, because the goal is just to determine if it makes sense, and it does. So we've done number 13 now. There's our 13. And number 15. There's our two intercepts, right here and right there. Okay, let's move on to our next couple problems, which were numbers 29, 31, 33, and 41. 29, 31, and 33, I believe, were all graphing problems. So let's go to those. Pretty close, okay. 29. So it looks like we need to have answered some of the previous questions. I think we need to do number 25 in order to answer 29, so that's what I'm going to do. Okay. For the following exercises, consider this scenario. The number of people afflicted with the common cold in the winter months, topical, steadily decreased by 205 each year from 2005 until 2010. In 2005, 12,025 people were afflicted. So I'm going to go ahead and find the inputs. So it says write C in terms of T. How do I know that? It says right here, find the linear function that models the number of people inflicted with the common cold, C, so that tells me C, as a function of year, T, so C of T. This tells me colds based on year. All right, well, let's write that function. Remember, this is going to be a linear function, it says. So we have y equals mx plus b, where m, remember, is the rate of change, and b is the initial value. Well, it tells me we have decreased by 205 cases, and we started in 2005. This is our starting value. We had 12,025 people. Now, in this example, if we're starting at 2005, I could start my graph at 2005, or I could think of 2005 as like my year zero. Because the first year we're talking about is 2005. And so that's just a way to quickly cheat some of the math. So let's go ahead and put this into y-intercept form. So in this case, C of t is equal to my rate of change. It says we decreased by 205. Well, decreased means negative 205. Decreased means we're going down over time, and 205 is our value. So negative 205 t, and then we have the initial value of 12,025. And again, I can verify that if I plug in my 0th year, which again, 2005 is the 0th year where we began our function, we would get 12,025, exactly as predicted. Now let's look at 29 specifically. When will the output reach 0? Well, if this is supposed to be our output, if it asks the question, when does the output equal 0, well, we can actually turn that into a function. 0 equals negative 205t plus 12,025. And we could actually solve it, which I'm going to do. I'm going to move the negative 205 over to become positive 205t. And then I'm going to divide by 205. I cannot divide by 205 in my head, so I'm going to use a calculator. All right. Take 12,025 divided by 205. We get an answer of t is equal to 58.658. And as it turns out, like, this interpretation tells me that in 58 years, in just a little over 58 years, I should say, the number of cases equals 0. So, in other words, by the 59th year, because this is bigger than 58, if we're thinking realistically, this is some time during 58 and 59, which means that by the 59th year, there will be 0 cases. And again, there's going to be some breakdown here, because what happens at the 60th year, when we go past this number? We can't have negative cases. They can't keep going down eventually, right? How do we get negative cases of the flu or the cold? Like, it doesn't make any sense. And so this tells me the two pieces it asks for. One with the output, specifically equals 0 at this value. And then we have to make sure to interpret it. So understand that that just means that in 58 plus years, the number of cases will be 0. All right, let's look at 31 now. Dealing with some more graphing problems. My favorite. So, for the following exercises, use the graph in figure 7, which shows the profit in thousands of dollars of a company in a given year t, where t represents the number of years since 1980. That tells me that at 0, 0 really means 1980, which means 10 would be 1990, 15 would be 1995, 20 would be the year 2000, and 25 would be the year 2005. Okay, 31. Find a linear function y, where y depends on t, the number of years since 1980. Okay, so in order to find a function, I have a bunch of different ways I can do this. I can use the rate of change and the initial value. That's what we've been doing. But we don't have these. We don't have the rate of change given, and we don't have the initial value. And even if you look at the graph, we don't have either of those either. We can also use 2 points is the other really common one. Now, they haven't given us 2 points, but they have given us a graph, which means we can find 2 points, and that's exactly what I'm going to do. If I look over here, I can see I have the point 15, 150. That's my first point. And at the other end, I have 25, 130. With these 2 points that are given from my function, again, 15, 150, 25, 130, I can determine what the slope's going to be, and then use the slope and the formula y minus y1 equals m x minus x1 to determine the actual value of the equation. So let's do that. Let's see. I have to plug into slope first. It always needs to be done first. So I do y2 minus y1 over x2 minus x1. I get negative 20 on top, positive 10 on bottom. These two cancel, leaving negative 2 over 1, or just negative 2. And now I can start plugging in. Again, this is going to be my slope. And now I'm going to use one of these points to plug in for x1 and y1. In this case, I'm going to use this one. And my slope, I'm going to plug in my formula. Y minus y1 equals m x minus x1. And then lastly, I'm going to take the time to actually figure out the other equation. So I'm going to take this equation, I'm going to rewrite it as a function with just y by itself. This is necessary because it says find a linear function y. Notice y is just listed by itself. It doesn't say y minus 150, it just says y. Find the function y. So I'm going to do that. I'm going to first start by getting the distributive property. Double negative makes it positive, and then 2 times 15 is 30. And then I'm going to add 150 to both sides. I get y equals negative 2x plus 180. And there's our function in terms of y as it requests. All right. 33 says find the x-intercept. Well, I'm going to go ahead and do 33 up here in the little blank space I got. Number 33 says find the x-intercept. To find the x-intercept, remember, one of the best ways we can do this is it just means I want my output equal to 0. So I'm going to take my function that I just found. I'm going to let it equal 0 and solve. So 0 equals negative 2x plus 180. I'm going to move the 2x over, give me 2x equals 180. Divide both sides by 2, x equals 90. Now, what does this mean? That means that 90 years after 1980, what was this thing about? The company will have 0 profit. How do I know that's what's happening? Well, x is representing the number of years. That's what it says in the problem. If you look over here, it says where t represents, oh wait, y in terms of dollars, as a company giving you t. Oh, I made a mistake. I shouldn't have x. I should have t. And so everywhere there used to be an x, I'm going to replace it with t. And everywhere there used to be an x, I'm going to replace it with t. And so I guess it should be the t-intercept. T and t. Man, I'm so good at this. All right. 90 years after 1980. How do I know it's after 1980? Well, it says it starts at 1980. So I know it's 90 years after that. And then how do I know this last part's about profit? Well, it says, which shows the profit y. So y value is the profit. So if y equals 0, that means the profit equals 0. And there it is. There's number 33. Moving on. Next couple questions. We got 41 and 43 next. Let's see, 41. Scrolling down. The same process goes for these ones. I recommend find 2 points, like the beginning and the end. You can try to find one in the middle if it's helpful, but I usually find those are harder. So it's up to you. Alright. 41 and 43. For the following exercises, use the median home values in Mississippi and Hawaii shown in Table 2. Assume that the house values are changing linearly. Okay? If we assume linear trends existed before 1950 and continues after the year 2000, the two states' median house values will be or were equal in what year? In this case, the answer might be absurd. Ooh. Okay. So if I want to answer that question on 41, it helps to have both equations. So I'm going to take some time here. I'm going to determine the Mississippi equation. I guess about Mississippi. And the Hawaii equation. Very similar to how we did it on the previous problem. And let's see how we go from there. For Mississippi, notice that I'm given 2 points. I'm given the year 1950. And we have 25,200. And the year 2000 as 71,400. Okay, so this is going to be my x value and my y value. And now I can start determining my rate of change. So my slope, m, is equal to y2 minus y1, so 71400 minus 25200 over 2000 minus 1950. The bottom one's pretty easy. I should get 50 on the bottom. On top, I'm going to get a negative number. Calculator is my friend. So I type in 252, other way. So it'd be 71400 minus 25200. We get 46,200. And if I divide that by 50, I get a rate of change of 924. And now we can interpret this. This tells me that every year the amount changes by 924. Since it's a positive 924, that means that every year it goes up by 924. This is going to be my m. And now I take my m and I plug into my equation. Y minus y1. I'm going to use the 2000 point. It doesn't really matter which one, as long as you use one of them. Which would be 71400 equals our slope, 924, x minus 2000. And then I'm going to simply solve. So I'm going to distribute first. 924 times 2000. So I get y minus 71400 equals 924x minus 1848000. And then I'm going to move that 71,400 over. Oops. Y equals 924x minus 1,776,600. So there's my equation for Mississippi. B. Alright, this is the same thing for Hawaii now. So for Hawaii, my points are a little different. My points are 1950, 74400, and then 2000 to 72700. Okay, so we find the slope just like before. M equals y2, 272,700 minus 74400 divided by 2000 minus 1950. Okay, once again, the bottom number is going to be 50. The top number is going to be 27200 minus, clear that out, 272,700 minus 71400, and I get 2121 or 201,300. Make sure I didn't make any mistakes. There was a mistake made. This should be 744. Okay, let me do that again. 272,700 minus 74400. I should get 198,300. Small difference, but important. Okay, now I'm going to divide that by 50. I end up with 3966. This tells me that every year the amount it costs to live in Hawaii changed by 3,966. So you can see it's growing a lot faster. That's a comparison we can make directly. And now I can actually start solving this thing. Y minus y1, so I'm going to use my 2000, equals m 3966 times my x1. Oh my gosh, I'm making mistakes all over the place here today. I apologize. 272,700 3966 x minus 2000. That's why it's always important to double check your stuff, because even the best of us make mistakes. And yes, I am saying I'm the best of us. Equals, okay, so 3966x using the distributive property, then take that times 2000. Wow, that's a big number. 7,932,000. So 7,932,000. Okay, then add that number over, which is 272,700, and we get y equals 3966x minus 7,659,300. Okay, we are still not done with 41 because the question asks us to assume they extended forever. At what point will these two values be equal? Remember, y is the value for Hawaii. All right? But y up here is the value for Mississippi. So if it asks when these two are going to be equal, what it's really saying is, when will that top equation, 924x minus 1776600, equal this bottom equation, 3966x minus 7,659,300. This is an important step because the question asks, when will the values be equal? Well, I need to know the equations so I can take them and make them equal to each other. Now I'm going to actually solve this thing. I'm going to solve this thing by moving this number over first and then moving that number over as well. If I do that, if I move the 7 million over, I get 5,892,700. If I move the 924 over, I get 3699 minus 924. I get 2,775x And then I take my solution to the previous part. And divide it by 2775. I get an answer of, let's see, make sure I didn't make any mistakes. Yep. I get an answer of 2123.49. And it should be negative. So this tells me that like 4,000 years ago, these would have had the same prices, which is interesting. Yeah, I don't think that's the case. I don't think they had home prices back then. But I mean, that's how the math works out. So I made a couple small mistakes in here. You see the flow of the problem. That's the big thing you need to know. That's the part you really need to understand in order to continue the problem, is you need to find the equations first. And my equations may be a little off, because again, I made a mistake once or twice. And then you just set them equal and solve. And it's this last step that's really important, because whatever answer you get, that is when these two will have the same value. Notice that it says the answer might be absurd. That's pretty absurd. So I'm guessing mine's pretty close. Alright, that was 41. Let's look at our last two, which are 43 and 45. Alright, 43. 43 states. Alright. If these trends were to continue, what would be the median home in value in Indiana in 2010? Okay, so just like with 41, I can't determine the value until I have an equation. But this time, I'm lucky. On 43, all I need to start with is just Indiana. So I'm going to ignore Alabama entirely and just go off what I have. So let's take a look. Indiana, we have in 1950, the value of your home was 37700. In the year 2000, the value of the home was 94300. I'm going to start by finding slope. 94300 minus 37700 divided by 2000 minus 1950. And then let's actually solve this thing. Let's see, the bottom number is going to be 50 again. Alright, the top number is 94300 minus 37700, which gives me an answer of 56600. If I divide that by 50, I get an answer of 1132. This is my rate of change. This is my slope. And now I can find the equation. Y minus a y value. I'm going to use this bottom one again of 94300 equals m, which in this case is 1132 times x minus 2000. And then I start solving. So y minus 94300 equals 1132x minus 2264,000. And I'm going to add that number over. I get this answer. Y equals 1132x minus 2169,700. Okay, this is my equation. And the question asks specifically, what's the price going to be at the year 2010 if we assume this housing market stays the same? Now, to answer that, in this case, the 2010 is a time. In other words, it's an x. So what I'm going to do is I'm going to plug in 2010 in for x and see what happens. So I do y equals 1132 times 2010 minus 2169,700. And let's get an answer. 1132 times 2010 gives me a value of 2275320 minus 2169,700. I then subtract those two. So 2275322 minus 2169,700. I get an answer of, in the year 2010, my value for y should be 105,620. So, at 2010, the price of your median home is 105,620, provided it follows this trend, which is pretty neat. Again, remember, these are used to make predictions, and that's exactly what it does. Okay, last question we asked about was number 55. Let's go ahead and put that up here. 55. When hired at a new job selling jewelry, you are given two pay options. Option A, and then option B. How much jewelry would you need to sell for option A to produce a larger income? Okay, so as with it was with 43 and with 45, I'm going to start by writing my equations. Thankfully, on 55, the equations are much easier to write. They've given me an initial value, and they've given me a rate of change, which means that for this one, for option A, my equation would be y equals the rate of change, it says, is 12%. Now, at 12%, that's 12 out of 100. Remember, you want to always make sure to convert any percentages over to fractions or decimals, times the number of sales, plus my base pay, which is 20,000. For option B, very similar. It says it's 3%, so that's my rate of change. You can almost always assume that if it gives you a percentage, it's probably your rate of change, although always make sure to read the context of the problem just in case. So there are my two equations. And it says, when will option A make more money? More money. Because if you don't make any sales at all, this top equation is going to get you $20,000, because 0 times that fraction is going to be 0, plus 20,000 is 20,000. And the bottom equation is going to get you 26,000. So if you make 0 sales, then B is going to make you more money. The question is, when does A flip the switch? Now, there's two ways to do this. You could graph this and see when does the bottom equation A eventually overcome the top equation. Or you could find out when they are equal, because if you know when they're equal, then where they become one bigger than the other has to be just past that. So that's what I'm going to do. I'm going to take these two equations, and I'm going to make them equal. So I'm going to do 12 over 100, x plus 20,000 equals 3 over 100, x plus 26,000. Okay. I'm going to move the 3 over 100 over here. I'm going to move the 20 over here. If I move the 3 over 100, I'm subtracting 12 over 100 minus 3 over 100. That leaves me with 9 over 100. And if you prefer, you can do it in decimal form just as easily. And if I move the 20,000 over, 26,000 minus 20,000 is 6,000. Okay, now I get x by itself by division. I can either divide by 9 over 100, which is an option. That'll get that to fix out and become just x. Or I could multiply by the reciprocal, which is another option. Let me go ahead and find my result. If I divide 6,000 divided by 9 over 100, 66,666.66. Okay. So you would need to sell $66,000 worth of equipment or materials in order to break even with these two. So anything past this would be an acceptable answer. So if you wanted to be really lazy, I guess my acceptable answer would be 666,666.67. That for sure is past this number. And this is going to be the first value where we actually get that change. And so this is my solution. Option A is better after this much sales. And that's number 55. Notice how we have to do a lot of these ones at the end of section 4.2. We have to focus on being able to find the equations first. It was a common theme in a lot of these problems was finding the equation first. And then once we found the equation, we have to then use the equation for something, which is its own specific problem. And so for many of these problems, they may look complicated, but you'll always notice they have a central theme, and that's a big detail to hold on to. That is it for today. If there are no other questions that I received so far at the time of this recording, we'll go ahead and sign off then. I'll be posting your homework assignment for the review sometime tonight, and I'll be posting the test itself on tomorrow during the day. And do note that the review, as always, is optional. And that's going to be it. Have a good rest of the day, guys, and I'll see you guys next time.